All right, students. So today we are doing IGCSE Chemistry P4 Variant 1 of October November 2024. All right, let's look at the first question. A list of chemical and physical processes A to H is shown. Combustion, diffusion, melting, neutralization, photosynthesis, whatever. State which of the processes A to H happens when an acid reacts with an alkali. What hydrolyzation reaction, right? The reaction is called neutralization reaction. So the answer would be, what is it? Not neutralization. We just have to write letter A. All right. So we will write only D, not neutralization. Next, reaches a position of equilibrium. Which of them is related to reaching a position of equilibrium? The only answer that is suitable is a reversible reaction, right? In reversible reactions, we reach equilibrium. Involves the particles changing from fixed positions to being mobile but still. All right. So this is talking about particles in fixed positions, that is solid, to being mobile. Particles in contact but still show translatory motion, that is liquid, right? So converting from solid to liquid, which physical state is that going from solid to liquid? It's called melting, right? It's called melting. C should be the answer. Next are physical changes. So which of them are physical changes? So melting is a physical change, C. And which else is a physical change? Well, diffusion is not a change. We're trying to look for something else. um Combustion is not a change. Diffusion can be changed, but let's just hope something else is present. Melting, neutralization, photosynthesis, reversible reaction, these are all chemical. Roasting, that is chemical. Thermal decomposition, that is chemical. Okay, so the only other physical thing is diffusion. um is it really a change? Well, it's change of position, that's all there is. Not D, sorry, B. So C and B, okay, is caused by gas particles colliding with each other. So what is caused by gas particles colliding with each other? One second. All right. So which of them is caused by particles colliding with each other? So gas particles, how do they cause? How do they collide with each other? That is called diffusion again, right? So this should again be B, right? It is not a chemical reaction though. Um, Next, this question is about atomic structure in the periodic table. Define the term nucleon number. What is nucleon number? Nucleon number is number of protons and neutrons in the nucleus of an atom or element, right? That is the definition of nucleon number. Next, state the connection between the number of occupied electron shells in an atom and the period number of that element. So what is the connection between number of occupied electron shells in an atom and the period number of that element? So, well, how can we tell? So period number basically tells us the number of occupied shells, right? So do we not look at a periodic table, say, oh, this element is in period 4, therefore it must have a total of 4 shells, right? That is number of occupied shells, right? So period number is basically the absolute definition of number of occupied shells. So we can say that period number is equivalent to number of shells. Next question. Write the electronic configuration of the following atom and ion. Okay, so this is an atom, this is an ion. We have to write its electronic configuration. It has 14 protons, therefore it must have 14 electrons. So we write 2 and 8, that is 10, and then we write 4, right? So that is the electronic configuration of silicon. Now the next, the electronic configuration of chloride. Now chloride has 17 protons, but it has also gained 1. So it has 18 electrons, right? It has 18 electrons. So the electronic configuration becomes 2, 8, that is 10, and then 8 more. So this becomes 2, 8, 8. All right. I hope that makes sense. So gained one electron. Okay, next question. Complete table 2.1. So we want to complete table 2.1. The first row says uh, 23, 11 Na. Number of protons are 11. Number of neutrons, how many neutrons does it have? Well, how do you find neutrons? You subtract the atomic number with the atomic mass, right? So 23 minus 11, that should be 12, right? Number of electrons should be equal to number of protons because it is right now neutral, right? It does not have a charge. That means all the protons and electrons are equal. This guy should have 10 electrons. Why should we say it has 10 electrons? Because it has 9 protons but a minus charge. Minus charge means it has gained an electron. All right, now this guy, it has number of protons 31, number of neutrons 38, and number of electrons 28. So if it has 31 number of protons, we don't know what it is. We should go and look in the periodic table who has 31 protons. All right, so just go to the periodic table. Let me just flip it so that I can see. So who has 31 electrons? So 25, 26, 27, 28, 29, 30. 30 is this guy. All right, 30 is this guy. 31 electrons has gallium has 31 electrons. All right, so we are going to write gallium, and then everything else we can calculate from over there. So let's go check. So this must be gallium. All right, because it has 31 protons, we write 31 over here. Why did I choose gallium? Because of 31. Why did I not choose anything because of 38? Yeah, why did I not choose anything because of 28? Because with a proton number, yeah, number of protons are the identity. All right, always remember that you have to choose the symbol of the element in compliance to the number of protons it has, right? So if something has 12 protons and 14 electrons, I cannot say that it would be silicon because silicon has 14 electrons. No, if it has 12 protons, it is magnesium. Now, if it has 14 electrons, then it is a very rare case that magnesium has gained 2 electrons. We know that alkali metals and alkali earth metals are highly reactive and they always lose electrons. But even then, if if we see something has 12 protons and 14 electrons, we will still insist that it is magnesium that has gained 2 electrons too. All right, I hope you understand what I'm trying to explain to you, that the number of protons are always the identity. All right, next, its nucleon number should be 31 plus 38, that is 79, right? And then its electrons are 28, which
69.
sorry, 69. Okay, it must be 69. Okay, next we have number of electrons. Number of electrons are 28 and number of protons are 31. That means there are three more protons. Therefore, gallium must have a plus 3 charge. Therefore, gallium must have a plus 3 charge. All right. On to the next question. A sample of thallium Tl contains two isotopes, 203 Tl and 205 Tl. Okay. Define the term isotopes. We have to define the term isotopes. All right. So isotopes are what? Isotopes are atoms of same element with same atomic number but different atomic mass. All right, you could have even said atoms of same element with same number of protons but different number of neutrons. That is also 100% correct. All right, the next question, the relative abundance of 203 Tl 205 Tl is in the ratio 3:7. All right, now for those who can see it from the eye, that means that 203 TL is 30% abundant and 205 TL is 70% abundant. Why did I just say that? Because right down here, they want to have us calculate the relative atomic abundance. So we write AR is equals to bracket percentage abundance multiply by
Isotopic mass.
isotopic mass. Let's just call it IR. Okay, I don't really know what we should call it, and divided by a
Is
100,
it a
right?
summation? Like
Yeah,
summation
there should be a
abundance?
summation. Yeah, summation. I forgot to write the summation. I forgot to write the summation. So this is the summation. ठीक है अच्छा. Next, after I've written summation, after I've written AR, ठीक है. Next, we have to understand that this said percentage abundance, and that is why it was divided by 100. That is why when I looked at this ratio, I converted it into percentage. But what if in a universe where you find yourself stuck, like for example, they say magnesium has 24 and 12 magnesium, and then there is a 26 and 12 magnesium, right? And there are in the ratio of 4 is to 5. Calculate their atomic abundance. Now, how would you, sorry, calculate not their atomic abundance, calculate their relative atomic mass. How could you do that? How could you do such a question? ठीक है बेटा देखो, the thing is you convert it into percentage or you solve it with ratios, the answer will always be same. That is how maths works. Okay, so for example, if I had done, if well, I know how I will do this one, because I'll just make two brackets. I'll say 30% multiply by 203 plus 70% multiply by, where is 3, multiply by 205, and then I'll divide by 100. But you should understand maths better. What is the meaning of ratio 4 is to 5? It means that if there were 9 atoms of magnesium, 4 of them would
4.9.
be 24 mass, and then 5 of them would be 26 mass. That means we've just found out the ratio. What could we have done? I'll show you with this one, because we are calculating that, right? Had done it, A is equals to bracket 3 plus 7 times 205. But instead of divided by 100, you divide by total parts of ratio. You divide it by total parts of ratio. All right, I've just received a message that I'm lagging. Is my voice better, beta?
Yes, sir.
All right. Um, 3 into 203 plus 7 into 205 divided by 10. All right. So if you do not have the percentage abundance and you have the ratio, all you have to do is multiply the ratios and divide by the total number of the ratio. All right. You could do the same for this one as well. You could multiply 24 by 4, and you could multiply 26 by 5 and divide it by 9. The answer would give you the same. Okay. Anyways, so what would be the answer, beta? Can someone calculate? I had a calculator. I don't know where it is now. Oh, it is very far away. I can see it, but I'd have to get up and get it. Anyone who has calculated this?
It's wait, no, it's 204.4.
Equals to 204.4. All right. So 204.4. And if you do it both ways, it should still be 204.4, because that is how it works in ratios. All right. So whether you do it in ratios or whether you do it in whichever way, the answer will always be the same. Just know that if the ratio comes out weird and you can't convert it into percentage, if you can't convert it into percentage, you can use the ratios themselves. All right. Just remember the denominator will be the total parts of the ratio. The denominator will always be the total parts of the ratio. All right. So, one second. Next question. Right here. Suggest why these two isotopes have identical chemical properties. Why do isotopes have same chemical properties? Because chemical properties are dependent upon valence electrons, and isotopes have same number of electrons, right? So they have,
Same electronic configuration.
yeah, same electronic configuration. That also makes sense. Electronic configuration. Next, copper 2 sulfate has the formula CuSO4. Aqueous copper 2 sulfate is a blue solution. A sample of aqueous copper 2 sulfate is made by adding excess copper 2 oxide CuO to hot dilute sulfuric acid H2SO4. Complete the simple equations for this reaction. Include state symbols. All right, so we have to complete the simple equation. Copper oxide, which is solid, right? It doesn't dissolve. We know that. We should remember that copper oxide is always solid. All right, H2SO4, we said hot dilute sulfuric acid. Acids are always aqueous anyways. All right, copper sulfate is a blue solution, it is going to be aqueous. And what is going to be the fourth product? When acid base react together, they produce salt
Salt
and
and
they
water.
produce water. All right, so this should be H2O. Okay, next question. State one observation which shows that copper 2 oxide is added in excess. One observation that you would say that copper oxide is added in excess. How would you know copper oxide is added in excess? Because copper oxide is insoluble. Because copper oxide is insoluble, right? If it is added in excess, by the end of the reaction, there would still be some solid left in the container that it is reacting, right? So you would see that some solid still remains after reaction, right? What you will write? Some solid still remains some solid still remains after the reaction. Next, describe how aqueous copper 2 sulfate can be separated from the reaction mixture. How could you separate aqueous copper 2 sulfate? So what is the way to collect something that is already dissolved? You evaporate it, right? You evaporate it. Evaporation or crystallization, both could make sense because we do not know. Well, technically you do know, but still you want to be careful, right? If something is a nitrate, you can't do evaporation. If something is a nitrate, you have to do crystallization. Why? Because nitrates are thermally unstable. We have studied that in the chapter metals, that nitrates, they undergo thermal decomposition when heated. So whenever something is a nitrate, you never crystallize. Whenever something has ammonium ion, you never crystallize because ammonia gas evolves from them. ठीक है? So you crystallize only you only evaporation is only done for things that are thermally stable. Copper 2 sulfate, we know very well that it is thermally stable. Sodium salts, a lot of them, not the nitrate ones, they are thermally stable. Most sulfates are thermally stable. All right, so those guys can withstand evaporation, but others you have to do crystallization. I hope that makes sense. Next
Sir, will
question.
it not be filtration?
What? How could you collect copper 2 sulfate from filtration?
Because it's going to be like crystal thoda.
No, there is not going to be at all crystal thoda. This is an absolute blue solution. Copper 2 sulfate. Okay, wait. It could be filtration. The reason why it could be filtration is because they're saying describe how aqueous copper 2 sulfate, meaning this solution can be collected from the reaction mixture, meaning the excess copper oxide, how you could remove it. Okay, yes, you are right. It should be, it should be filtration then, right? Yeah, filtration. We have understood the question wrong. We were trying to separate out copper 2 sulfate ke crystals, but in this question you were not supposed to separate copper 2 sulfate ke crystals. You were supposed to separate aqueous copper 2 sulfate from the reaction mixture, meaning from the copper oxide, from the copper oxide. All right, so it should be filtration. Okay. Next question. Crystals of hydrated copper 2 sulfate can be obtained from aqueous copper 2 sulfate by crystallization. All right. State what is meant by the term hydrated. What is meant by the term hydrated? Hydrated means which contains water, right? A substance which contains water of crystallization. Water of This means that water molecules are trapped within its crystal lattice. Write the formula of hydrated copper 2 sulfate. So what would be the formula of hydrated copper 2 sulfate? It is very famous, CuSO4.5H2. Copper 2 sulfate has 5 molecules of water stuck to it always. Okay? Describe how this crystallization is done. How this crystallization is done, they're talking about this crystallization. How do we do crystallization? So to my question, we heat the solution till we see precipitates of copper 2 sulfate forming at the base of the mixture. Yes, solution. Okay, we heat the solution until we see precipitate of blue crystals form. We Until we see precipitates of blue crystals forming. Full stop. Then we stop heating and place the solution in our drying tray and allow more crystals to form. Full stop. All right. So this is how you do it. Okay. So basically, have we mentioned we'll allow it to cool? We heat the solution until we see precipitate of blue crystals forming. Then we stop heating and place the solution at drying tray and I'll more. अच्छा हाँ सही है तो in the middle we ate the sentence. Allow the solution to cool so that more crystals form and allow the solution to cool down. This is the most very important part of crystallization. Allow the solution to cool so that more crystals can form. Full stop. Next question. Aqueous copper 2 sulfate undergoes electrolysis using graphite electrodes. State why aqueous copper 2 sulfate conducts electricity. It has free flowing ions. It has free flowing ions. If someone says it has
IT.
free, oh, sorry, I wrote if. It has. I did not write has either. It has free flowing ions. All right. So free flowing ions. That is why if someone writes if it has free flowing electrons, wrong answer. Okay. Ionic compound do not have free flowing electrons. Give two reasons why electrodes are made up of graphite. First reason, graphite is a good conductor of electricity. That is one reason. Graphite is a good conductor of electricity. So yeah. Second condition, it is inert. It is inert at room conditions especially. All right, there is only one instance in your whole syllabus where you see graphite reacting, and that is during electrolysis of molten aluminum oxide, right? In the purification or the extraction of aluminum, you do electrolysis of molten aluminum oxide with cryolite. The formed oxygen reacts with graphite anodes and produces carbon dioxide, because graphite is made up of carbon, but that is 900 1000 degrees Celsius conditions, right? At room temperature, graphite does not react with any. Next question. Describe how the appearance of the electrolyte changes during the electrolysis of aqueous copper 2 sulfate. During aqueous copper 2 sulfate, when you electrolyze this solution, we have done it in our notebooks. We have done it in the notes, right? Copper 2 sulfate, when it is in aqueous state, when it undergoes electrolysis, the hydroxide ions go to the anode and the copper ions go to the cathode. Now the solution was blue in color. The solution was blue in color because of the copper ions. If the copper ions are getting discharged and forming copper atoms, that means copper ions are decreasing from the solution. And as the copper ions are decreasing from the solution, we say that the blue color of solution gradually fades. What do you say? Blue color of the solution
Becomes lighter.
gradually fades. Yeah, becomes lighter, meaning gradually fades. Same thing, both things, right? Next, describe what is seen at the cathode during the electrolysis of aqueous copper 2 sulfate. What is seen at the cathode during electrolysis of copper 2 sulfate? So, at the cathode, we would observe what? We would observe the cation going and getting discharged. Now, there were two cations in aqueous copper 2 sulfate, the copper ion and the H plus ion. In the condition, yeah, in the case of copper 2 sulfate, H plus is more reactive, Cu2 plus is less reactive. Therefore, the lesser one gets discharged. Therefore, copper ions go and get discharged at the cathode. So we say that the size of cathode increases. या फिर something is depositing on the cathode. And what is that something? It is copper metal depositing. And how do we recognize copper metals? We recognize, or it's very famous, we say that a pink metal, a pink solid deposits onto the cathode, making cathode bigger, right? So we say pink solid deposits on cathode, making it larger, making it larger. Next question, write the ionic half equation for the reaction at the anode. So what would be the reaction be? What would the reaction be at the anode? At the anode, we know that there is sulfate ion in the solution and there is hydroxide ion at the solution. In this condition, the hydroxide ion will get discharged because sulfate is way more reactive, right? Sulfate is very much reactive. So what do? We write the ionic equation of hydroxide ions. And what do we see about hydroxide ions? We have to memorize this. It is 4OH minus aqueous, right? It will produce one molecule of oxygen, meaning 1 mole of oxygen gas. It will produce 2 moles of H2O, which will be liquid, and it will produce 4 electrons, right? At anode, electrons are lost. This is the half ionic equation for hydroxide ion and its um, decomposition. Next question. State two differences seen if the electrolysis is repeated using copper electrodes instead of graphite electrodes. If we don't use graphite electrodes, if we use copper electrodes, then what would we do? Now, this is once again for those who had studied from my notes, they would find that this is also repeated. This is also repeated in my notes, right? And where is it repeated? It is repeated in the industrial processes or industrial electrochemistry, and in that we studied electrolytic purification of copper, electrolytic purification of copper. So we have impure copper and then we want to purify it. How do we do it? We make an electrolytic cell in which we use the cathode as pure copper cathode, and then we use the anode as impure copper anode. So this kind of resembles it, and then we have the solution of copper 2 sulfate in it, right? What happens is the copper from the anode migrates to copper from at to the cathode, right? So the solution does not change. So in the condition where we use reactive copper electrodes, the copper ions in the solution remain same throughout the electrolysis. And if the copper ion concentration in the solution is the same, then the color of solution remains same, right? The color of solution remains same. Next, state two differences seen if electrolysis is repeating using copper electrodes instead of graphite electrodes. All right, the next observation. Now that there were three observations about it that we wrote in my notes, right? We wrote the solution does not change color. We wrote the cathode becomes larger in size, and we wrote the anode shrinks, right? Now, two things that are not seen when you use graphite electrodes. We do see the cathode becoming larger. So the next observation, we cannot write the cathode becomes larger as the size of cathode increases. No, 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 no. That would be wrong. We have to write the size of anode decreases, because in the above experiment, when we were using graphite electrodes, they were not decomposing. The anode was not decomposing when we were using graphite electrodes, right? So we will say the anode decomposes and shrinks in size. The anode decomposes.
But so even in whilst using graphite electrodes, the size of the electrode increases
Size of
at the
cathode
cathode?
increases. Yes, the anode decomposes and shrinks in size. Let me just show you how from the notes, beta. So you need to have the knowledge of the notes as well. The thing was, we study that in electrochemistry, right? Right here, I think we studied. Okay, so here's the electrolytic purification of copper, right? When we use copper electrodes, right? So we use
Yeah,
pure
yeah.
copper cathode and we use pure copper anode. The thing is, when we use reactive electrodes and the solution of them, right? What happens is the anode ionizes and deposits at the cathode, and the overall concentration of the solution remains same, right? So that is what we see. So after the reaction, we see the anode shrinking in size and the cathode increasing in size, because all the copper ions from the anode go into the solution and then get deposited onto the cathode. Okay, it is that easy. Now, if we use copper to sulfate, right here, electrolysis of, where is it, electrolysis of dilute concentrated copper to sulfate, the equation. Okay, so I have not drawn the diagram in this one. Let me see if I have drawn the diagram in the other electrochemistry notes that I have. 1 second. If I have, then it will be great. If I have not drawn over there either, then I'll have to draw it and show you. Okay, so it seems I have not drawn it over here as well. But um, the thing is, look, even if we use, so I'll just make a new page and show you that page. Let's suppose, beta, let's suppose here's the solution, right? Let's suppose here's the solution, and the solution contains a graphite anode, all right, and it contains a graphite cathode, all right, and it contains solution of CuSO4 aqueous. All right, we know that it is going to be connected from the battery at the top. That doesn't really matter right now. This is the graphite anode. Anodes are positively charged, you should know that. And this is the graphite cathode. Cathodes are negatively charged, you should know that. All right, now there are Cu+2 ions, there are H positive ions, there are SO4 minus ions, and then there are hydroxide ions. These four ions are in the solution, right? Now out of them, who will go to the cathode? Either copper or hydrogen. But who does copper ions go to the cathode? Why? Because they are less reactive. And because they go to the cathode, even if this is made up of graphite, copper ions go to the cathode and they start depositing. What would happen to the cathode then? The size of cathode would increase. All right. So whether you use graphite anodes, or whether you use graphite cathode, or whether you use copper cathode, the size of copper cathode increases, because hydrogen needs discharge. Or over here, who's getting discharged? Copper is getting discharged, right? Because copper is getting discharged, therefore you observe that this happens. I hope that makes sense. But the anode only decomposes or shrinks in size for our other reaction in which we use copper electrodes. All right.
Okay.
Next question. When magnesium nitrate is heated strongly, magnesium oxide is formed. The equation for this reaction is shown. Magnesium nitrate undergoes thermal decomposition, whatever, whatever. State the change in oxidation number of nitrogen N in this reaction. So how has the oxidation state of nitrogen changed? So for that, we have to judge the oxidation state of nitrate over here, and then we have to judge the oxidation state of nitrate over there. Okay. For that, they give us 2 marks. So how will we judge the oxidation state of NO3 over here? Beta, the thing is, you should know that NO3 has a -1 charge, right? NO3 has an overall -1 charge. Nitrate has a -1 charge, right? It's a nitrate, it's an ion, right? That means that one nitrogen and three oxygens, they combine together to give a -1 charge. Now, We have taught you that for your level, you should always remember that oxide is -2 charged. All right. So nitrogen plus 3 times -2 is equals to -1. So what is nitrogen? Nitrogen -6 is equals to -1 because 3 times -2 is -6, right? So what is
So
nitrogen?
5.
Nitrogen is -1 plus 6, yeah, which will be 5 plus 6, which will make nitrogen plus 5. So initially, nitrogen has a charge of plus 5, okay? Now, once
Do we count
nitrogen,
the 2? Like, do we multiply it by 2?
we multiply it by 2 like this. No, no,
Yeah.
nitrogen is plus 5.
Okay.
We only find the charge of nitrogen in NO3. NO3 का overall charge -1 है ना, तो उससे हमने नाइट्रेट निकाल लिया. अब अगर हम लोग इसको 2 को कंसीडर करें, then what will happen is कि we will do twice of everything, then we will do twice of this, so it will be -2 charge over here and 2 nitrogens, and then at the end the answer will still be plus 5. All right.
Oh, okay, okay.
Okay, so nitrogen initially was plus 5. Now what is nitrogen in NO2? NO2 we can just calculate right over here. It's easy. Two oxides. Now look, when we are finding charges, we don't really consider this 4 or anything. Okay? So what is the charge on nitrogen over here? O2 is -4 over here because two oxides means 2 times -2, right? So that gives us -4. So if O2 is -4, one nitrogen is countering that, so nitrogen
Plus
should be
4.
+4,
Yeah.
right? So the charge on nitrogen has gone from +5 to +4. Identify which element is oxidized in this reaction. So which element is going to be oxidized in this reaction? So the only element that seems to have oxidized, look, how would we know? So nitrogen has not oxidized. This has been confirmed, right? Nitrogen has gone from +5 to +4. This is reduction. This is what? This is reduction. All right. Magnesium has gone from +2 to +2, meaning it has neither oxidized nor reduced. Now, I mean, there is no other element other than magnesium, nitrogen, and oxygen. That means if nitrogen has reduced and magnesium is a spectator, oxygen must have oxidized. So simply the answer should be oxygen, but how can we confirm that oxygen has oxidized? How can we confirm oxygen has oxidized? Over here, before the reaction, each oxide had a -2 charge, right? Each oxide had a -2 charge. We had confirmed that, right? Now, when it becomes a diatomic molecule over here, when the oxide has become a diatomic molecule over here, it means that the oxide has gone from -2, the oxide has gone from -2 to 0. The oxidation state has increased. The oxidation state has increased. Going from -2 to 0, the oxidation state has definitely increased. So we say the oxidation state increase of who? Of oxygen. I hope that makes sense. I hope everything is clear. We shall move on now. Okay, next question. Let me just write oxidation over here as well so that you guys understand. So I hope you guys understand that oxygen is the one that is oxidized. How do we know? Because the charge of oxygen increased from -2 to 0, or increase in oxidation state is called oxygen. Now if some of you had the thought or had the idea that sir, oxygen was like the thing that makes others oxidize or reduce, how can it be oxidized? But oxygen and hydrogen, they themselves can also get oxidized or reduced as well, because the term oxidation or reduction is referred to by 4 different examples. If any of those definitions satisfy a situation, then that situation is either oxidation or reduction, judging of which definition it satisfied. So for now, the definition that it satisfied is the oxidation state increased.
Okay.
Next question. Calculate the volume of NO2 gas at RTP formed when 7.40 grams of magnesium nitrate is heated. Use the following steps. When they give us 7.40 grams, I mean, the MR should be 74, right? Otherwise, why do they give it 74 grams? But let's just find out if MR is 74. So what is the mass of magnesium? Magnesium is
24.
24, right? Plus, what is the mass of nitrogen? 14. And what is the mass of 3 oxygens?
48.
48. And then we have to multiply this by 2, right? Because it's whole twice. Right? So this will become 24 plus what is 2 times 14? Or you could just do 14 plus 48 before and then do 2 multiply by it. Both ways the answer will be same. This is called commutative law of multiplication and addition. Jaldi jaldi. What is
148.
just
Oh,
this
the
much?
total is one.
I
No, no,
think
no, no.
I
The
think you're
total
telling me
is
the total. Yeah.
it's
I would have
124.
liked 124. All
124.
right. So 24 plus 124 is 148. So my theory was wrong. Its mass is not 74 indeed, but it is 148. And I know why it is 148 because half of 148 is 74. See, which is close to 7.4. Calculate the number of moles. What is the formula of moles? Moles is equals to mass
Mass upon MR.
upon mr. Mass is 7.40 divided by mr is 148. 7.40 divided by 148 is 0.05.
0.05.
क्या बात है 0.05. Next, determine the number of moles of NO2 formed. This is where we use comparative analysis or ratios. We say how much magnesium nitrate was required, ratio how much NO2 formed. Okay, the equation says 2 is to 4 ratio, right? The ratio is 2 is to 4, as you can see. You can see that ratio is 2 is to 4, right? I hope you can. So the
Yeah.
ratio is 2 is to 4. For now, this is 0.05. This is x. X should definitely be 1 because it's only going to be double of 0.05. But you can try and find it by the cross multiplication method. There is nothing wrong with doing cross multiplication. No one is going to say, oh, you weren't smart enough that calculated in your head. You can just do 4 times 0.5 divided by 2. The answer you would get is 0.1, however. Okay? But
Yeah.
you can confirm 0.1. Calculate the volume of NO2 in cm cube. The volume is equals to mole multiplied by
Multiply by
24,000.
24,000.
Why 1000? Because we want it in cm cube. If you did multiply by 24, you would get in dm cube, and then you would later multiply that dm cube by 1000. Matlab the same answer would be obtained, but you do two steps. We'll do just one. 0.1 multiplied by
2400
24,000 is going to
is
just push the decimal back once, so it's going to be 2400 cm cube. So the answer is 2400 cm cube. Okay, I hope that makes sense. Let's move on to the next question. Magnesium oxide MgO is an ionic compound. Complete the dot and cross diagram in figure 4.1 of the ions of magnesium oxide. Give charges of each of the ions. So magnesium has a +2 charge after it loses 2 electrons. All right, and after it loses 2 electrons, it is only left with two shells, right? One shell is drawn by the Cambridge guys themselves, and one shell is what we had to draw. So we've drawn the other shell. The other shell must contain all electrons of the magnesium. Why should it contain all electrons of the magnesium? Because magnesium is the metal and it does not gain anyone's electrons. So it has its own electrons in its inner shell that are seemingly complete. Okay. Now, oxide has a -2 charge because it gains 2 electrons. That is something we should remember. The next thing we should remember is that oxygen contains only two shells, right? And after even gaining electrons, it won't contain a third shell. It will still contain the two shells because the two shells weren't complete. But after gaining two electrons, the two shells will now be complete. How will we show the two shells are complete? We'll just put two crosses and then 6 of oxygen's own electrons will be shown alongside it. All right. This is how you will complete this dot and cross diagram. There is nothing more to it. It is a very straightforward,
So I have
simple
a
way
question.
of doing it. G.
Why do we write +2 and -2 when we've basically like filled out their valence electron?
Why do we write +2 and -2?
Okay, wait, never mind. Sorry. I get it.
Okay. It's good that you got it. Uh, I didn't want to fly to Qatar to smack you, so you remember. Okay. देखो, वैसे अगर किसी और के दिमाग में भी ये सवाल आ रहा है या कोई रिकॉर्डिंग में भी ये सुने, देखें, it is very easy to remember. Look, the reason why something is called +2 is because it now has two more protons than electrons. Once you lose an electron, you automatically have one more proton. So you have one plus one charge extra, right? And once you gain an electron, what happens? there is now an overall one more electron than there is proton. So whenever there is one more electron than proton, then it means that there is going to be one extra negative charge. So if something gains two electrons, like our brother oxide, it now has two more electrons than it has protons in its nucleus, therefore it has a -2 charge, like that. Oxygen is a covalent molecule. Complete the dot and cross diagram. This is something that is also mentioned in the notes. This is a double bond, right? Oxygen, the O2 forms a double bond. And because there are six total electrons in its outer shell, so okay, I am doing it wrong because this side is dot one, though we have to do dots. So because there are six, so two are shared, four are not. Similarly over here, two are shared, four are not. Next question, very easy question. It was up above. Hydrogen is the first element of the periodic table. Hydrogen is used in fuel cells to produce electricity in vehicle. It seems that they have changed the way they ask in this October November paper. If you guys notice, we are already on question 5 and we haven't seen much Lee Chatelier or energetics anywhere. Or judging by the looks of it, there are usually 7 questions. So I don't know how they are going to cram organic chemistry and all those topics. So they focus highly on the basic topics in 2024 October November. I don't know why. This was a very easy paper so far. Hydrogen is the first element of the periodic table. Hydrogen is used in the fuel cell to produce electricity. Name the substance which combines with hydrogen in a fuel cell. All right. So which substance combines with hydrogen?
Oxygen.
Very good. All right. A fuel cell is called a fuel cell because it contains oxygen, and then whichever fuel cell it is called, that is the second fuel. So a hydrogen fuel cell is the fuel cell in which hydrogen and oxygen are present. If, for example, it was a magnesium fuel cell, then the fuel would be magnesium and oxygen. Oxygen is always constant, right? ठीक है भाई. Next question, give one advantage and one disadvantage of using fuel cells instead of gasoline in vehicle engines. So why do we want to use fuel cell? What would be the advantage? It doesn't produce any greenhouse
Yeah.
gases, right? It does not
Environmentally
produce,
friendly.
yeah, it is environmentally friendly. It does not produce greenhouse gases. It does not produce greenhouse gases. Full stop. All right. Next question. Give one advantage and one disadvantage of using fuel cells instead of gasoline in vehicle engines. सही है. तो वन एडवांटेज दे दें, वन डिसएडवांटेज दे दें आप उसका, कि गैसोलीन, ओ सॉरी, तो एडवांटेज तो दे चुके हैं, डिसएडवांटेज देना आप. सो व्हाट इज द डिसएडवांटेज? द हाइड्रोजन ऑक्सीजन फ्यूल सेल इज extremely reactive, right? So
It's
it is
hard to
dangerous.
contain hydrogen.
Yeah, very good. It's hard to contain and
Expensive.
it's difficult and unsafe to store hydrogen. Full stop. All right. Next question. Hydrogen gas can be made from petroleum by a two-step procedure. Petroleum is separated into different components. Large molecules obtained in step 1 are converted into smaller molecules, including hydrogen gas. Name the process used in step 1. Okay, so petroleum is separated into different components. That was called?
Fractional distillation.
Oh, so they've just transitioned into organic chemistry from over here. Nice. Fractional distillation. Next question, name the process used in step 2. So, a large molecules obtained in step 1 are converted into smaller molecules, including hydrogen gas. So, they are breaking large molecules into smaller molecules and hydrogen. That was called cracking, right? That was called cracking. We usually do cracking of large chain alkanes to produce
Is
a
it
smaller alkane.
catalytic cracking or just cracking?
I mean, it requires a catalyst, but you don't have to write catalytic. You can just write cracking. We know that
Okay.
it is catalytic cracking. In your syllabus, you don't have to know the name of the catalytic cracking, the catalyst. But if you want to remember, the catalyst used in cracking is aluminum oxide Al2O3. It is the most famous one. All right. You want to write that down, you can write that down in your notebooks. Aluminum oxide Al2O3 is used as a catalyst in cracking. Next question. Organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of ester methyl propanoate. 1 mole of CH3 CH2 COOH contains 6.02 into 10 to the power 23 molecules. Now that is Actually a beautiful question, because look, it is a 4 mark question, but it is such an easy question. Look, they have given us mass.
Why did they give us Avogadro's constant?
I mean, how else could you have found it?
But then wouldn't it be like super
You,
easy?
yeah, I mean, yeah, you're saying it should be that you remember it.
Yeah.
Yeah, they try to narrow down or decrease the amount of memorization you guys need to do, especially in chemistry and physics. They are like, you don't have to remember all the numbers and all the constants. You can just try and not remember some of them. Okay, so like even in physics, you should know, in space physics they say that you should remember the Hubble's constant, but then sometimes they give you the Hubble's constant in the question, right? Even though it's a difficult value to remember. So similarly in chemistry, sometimes they give you, sometimes they don't. But the aim of the question and the 4 marks for the question are, I don't understand why, but it is very simple. Look, in stoichiometry, I have taught you nothing goes to nothing without going through moles, right? So we are given the mass,
No, mass to mole and then mole to amount of substance.
and then mole to we go to number of,
Atoms.
nope, we go to number of molecules because this is a compound, to number
Yeah.
of molecules, and then from number of molecules we go to number of hydrogen atoms. All right, this is the
Okay.
pathway we have to take. This is the 3-step pathway that we have to take. All right, okay. Now how do you go from mass to mole? The answer is very simple. You divide the mass from the mr. All right, how do you go from mole to number of molecules? You multiply the moles by 6.02 into 10 to the power 23. How do you go from number of molecules to number of hydrogens? You multiply by number of hydrogen in one molecule. All right. So I'll explain in a simpler terminology as well. But for now, let's just solve this question first, and then I'll find space to solve. Help you guys. All right. So first we find moles of, and let's just write it as a single one. So it's called methyl propanoate. So there should be 4 carbons. All right, there should be 8 hydrogens and there should be 2 oxygens. If you want to count, you can count 3, 2, and 3. That is 8 hydrogens, and 1, 2, 3, 4. That is 4 carbons, and then 2 oxygens right in the middle, as you can see, C double O. Right. So that is the formula, C4H8O2. All right, and mole
This is
is equals
an
to,
ester.
yes, beta, mass upon
Okay.
mr. It is said ester, but if even if it did not say, the name should give you the hint, right? Okay. So what will we get? Beta, mass upon mr. Mass is 44. All right. Mr we can calculate on the side right here. 4 times 12 plus 8 times 1 plus 2 times 16. So that should be 48 plus 8 plus
88.
32. So it should be 88. All right. So 44 upon 88, that is 0.5, right? That is the first step. Now number of molecules, C4H8O2. All right. We'll do number of molecules equals to mole multiply by Avogadro's constant Na equals to
8
0.5
point.
times
Oh, okay.
6.02 into 10 to the power 23. Yes, you are right, Mariam. 3.01 into 10 to the power 23 molecules. ठीक है? Hydrogens, number of hydrogen atoms. So number
What's
of,
surprising is that they didn't break this question down like they normally do.
I mean, that is surprising for IGCSE students because you are used to getting uh, questions broken down. In O levels, questions come like this. They never come in broken down forms like you guys see, right? So this everything you have to do it yourself. And I mean, if any of you have taken my O levels classes, me solving O levels past paper questions, you would have seen me draw 3 columns. And I always say, beta, you have to understand what is given to you, what is asked from you, and what two values you have to compare or something, right? And similarly,
Mm.
questions like these as well, you have to make this mind map yourself. So how are you going to travel to number of hydrogens when you are given the mass? You go to moles, you go to number of molecules, then you go to number of hydrogen atoms. All right, so these things you have to know yourself as well, better don't rely on anyone, right? And practice enough that you know them yourself. Number of hydrogen atoms, so we say number of atoms per molecule multiply by number of molecules equals to, so how many number of molecules are there? Three, number of atoms per molecule is 8 times 3.01 into 10 to the power 23. So 8 times 3 is 24, 24.08 into 10 to the power 23. So it should be 2.401 into 10 to the power 24, right?
Sir, can you just explain the last part?
Yeah, that is the part that I knew I'll have to explain, and I'll explain. Okay, so 1 second, let me just write the answer in a box kind of thing. So let me just do 2.408 into 10 to the power 24, and this gives us our 4 marks. ठीक है, ये हमारा final answer हो गया. Bye. All right, why is it like this? Better just understand this. Let's suppose this is our molecule C4H8O2, right? Okay. And the question asked how many hydrogen atoms are required to make 7 such molecules. So what is the
7
question?
times 8,
Yeah, why did you do 7 times 8
because we need 7 like such
molecules?
molecules.
And each molecule contains how many hydrogens?
8.
That is how our brain works, right? So let's suppose if we have a bag of Maltesers and there are 12 Maltesers in one bag and we have 24 friends. So how many bags of Maltesers should we buy so that at least
2.
each friend gets one Malteser? So
2.
how did you do that? So you said each
12
bag contains
divided by 2.
12. So there are 24 friends. So 12 divided by 24 or 24 divided by 12 is 2 bags, right?
Hmm.
You understand? That is how we work out, right? Now, similarly, they asked us how many hydrogen atoms are there in 44 grams of ester, right? 44 grams of C4H8O2. So for that, we found out how many moles that is, 44 grams, right? Then we found out how many molecules of C4H8O2 are there. So we found out that 3.01 into 10 to the power 23 molecules are there. I've written moles. This is wrong. This is molecules, right? Molecules of
So
C4H8O2 are there.
3.01 multiplied by 10 to the power 3 is
23.
like all of them, like 4, 8, and 2 of
Yeah,
carbon, hydrogen, and oxygen.
is the molecule.
Yeah, of the
The
molecule. Okay.
molecule, right? And then each molecule
So why aren't we
contains
dividing
8
it?
hydrogen because each molecule contains 8 hydrogens. इतने molecule है बेटा, इतने bags of Malteser है. Every bag contains 8 Malteser. So will you divide the number of bags by 8 or will you multiply it to find out the total Maltesers inside it? Look,
Can you repeat that?
yes, it seems like
Repeat, no, just repeat the last part you said.
I don't even remember what I said. I was saying, like, consider this. Okay, this is your branded C4H8, right? It is like a mixed fruit jelly. All right. It contains 2 oxygen jellies, it contains 8 hydrogen jellies, and it contains 6 carbon jellies. Now you are asked
For
how many hydrogen jellies are in 11 such packs?
But it's not asking for 11, right? It's asking for in one molecule.
What? No, it's asking how many hydrogen. Why am I raising? It's asking how many total hydrogens are there. So
In
if
one
it
in
said,
one molecule.
no, it does not say one molecule. It says in 44 grams.
Okay.
It says in 44 grams. Where does it say in one molecule?
Okay.
It it told us that one molecule contains 8 hydrogens by the formula, right? So now understand it from the very scratch again. Try to understand it. It's basic maths, nothing else. Only arithmetic. If one molecule of C4H8 contains 8 hydrogens, as we can see in the formula, right? When we calculated it out, we found out that 44 grams of this ester, methyl propanoate, contains 3.01 into 10 to the power 23 molecules. You can do it like this as well.
Oh,
Just,
okay, I got it. I got it.
okay, sugar, alhamdulillah.
Yeah.
So, it is a very easy question, beta. Please don't mix it up. The only reason students mix it up is because they are not used to such big values. They are not used to a value that has 10 to the power 23. But what does it matter? It's only a number. Treat it like all other numbers. Treat it like 10, treat it like 11. You should always treat mole like you treat a dozen. A dozen is
Okay.
12, so you are easy with it. But a mole is 6.02 into 10 to the power 23. So all of a sudden it looks like it's a very drastically big value, so you should be more careful. No, you should be just as careful as you are with the dozen. Like 2 dozens is 2 times 24, so 2 moles is 2 times 6.02. Okay.
Okay.
Next question. For each of the homologous series shown, name a member that contains 6 hydrogen atoms. So we want to name for alkanes a 6 hydrogen atom member, that would be hexane. Okay. For
Ethane.
alkene, sorry, kya?
Ethane.
We want to, oh sorry, 6 hydrogen atoms. 6 hydrogen atoms.
Yeah. Not
Sorry,
cutting.
sorry. 6 hydrogen atoms. So 6 hydrogen atoms are in C2H6, right? So that would be ethane. All right. This guy, it has 6 hydrogens when it has three
Propene.
carbons. So it would be propene,
Mm-hmm.
right? This has 6 hydrogens when it has 2 carbons because C2H5OH, that is 6 hydrogens. So this will be ethanol. All right. And then carboxylic acid. The most difficult one is carboxylic acid for you guys in exams because you will want to remember what comes over here. But for that, you need to know the general formula. So, what is the general formula of carboxylic acid? Anyone remembers?
CnH2n plus 1 COOH.
Good. Yes, that is. And there is also an alternative one which is easier for this situation. ये तो है बिल्कुल आप सही कह रहे हैं CnH2n plus 1
So Cn plus
COOH.
1 H2n plus 2.
नहीं, not that. CnH2n plus 2 O2. This is also a formula.
Okay. But what happens
Sorry,
to
sorry.
this? Yeah.
CnH2 and O2. This is the formula. Okay. So
Okay.
both these formulas are the same. But इस formula में we consider n one less. We consider n one less than the total number of carbons. Meaning in this condition, if the total number of carbons was 6, so n would be considered 5. And if in this condition n is the total number of carbons, right now we just have to write the name, and the name is dependent on the total number of carbons. We can see that however many carbons there are, hydrogens are twice.
Propanoic acid
Yeah, kind of
is just
like in
double.
alkene, right? Kind of like in alkene, because alkene is also CnH2, and that's why it's for propene. So this will be propanoic acid. All right. So we like this formula better. C3H6O2. Why? Because the general formula is CnH2n O2. All right. And then this one's general formula is CnH2n plus 1 OH. And then this one's general formula is CnH2n plus 2. Okay. On to the next question. Unsaturated alkenes are converted into saturated alkanes by reaction with hydrogen gas. State why alkenes and alkanes are hydrocarbons. Because they contain carbon
and hydrogen only.
and hydrogen only. State why alkenes are unsaturated. Alkenes are unsaturated because they contain carbon-carbon double bond, right? Name the catalyst needed to convert alkenes to alkanes. Which catalyst did we use? We used nickel, right? Or we could also use platinum. Platinum is also a catalyst that we can use, but the more famous one is the nickel that we use. ठीक है? सही है? Okay, right. Next, explain why the conversion of alkenes into alkanes is an addition reaction. Because only one product forms. Any reaction is an addition reaction when only one product forms. Any organic reaction. It should be from organic chemistry, right? Only one product is formed. Suddenly आप ये ना बोलो ना सर के copper oxide and carbon dioxide, when they react at very high temperature and pressure, they produce copper carbonate CuCO3. So that should be addition as well because only one product. No, it's not organic reaction. Okay. Next question. Natural polyamides are polymers made from amino acid monomers. State the type of polymerization reaction that occurs when natural polyamides form. The type of polymerization that takes place when polyamides are
Addition?
formed.
Condensation. Oh,
Condensation.
oops.
Addition is when alkenes are polymerizing. Condensation, polymerization. State the term given to natural polyamides. So the term natural polyamides that are made from amino acids, what are they called? Beta proteins.
Yeah.
Good. Okay, they are called proteins. An amino acid is represented as shown in figure 6.1. All right, we can represent it like this. Complete 6.2 to show the general structure of an amino acid. Show all of the atoms and all of the bonds. So we have to show all the atoms and all the bonds. I like to show the carboxylic acid on this side. C double bond O O H. All right. We have R over here. We have N over here. All right. And then N is joined to one hydrogen and another hydrogen. This is why it's called the amino acid. Okay. Any problems? I hope not. Next question. Three different amino acids are represented as shown in figure 6.3. Amino acid A, B, and C. Complete the diagram in figure 6.1 to show the part of a structure of natural polyamide that forms when the three amino acids A, B, and C combine. Show all the atoms and all the bonds in the linkages. ठीक है भाई. All the atoms and all the bonds. Amino acid A, well, it has nitrogen, but the nitrogen has a hydrogen over here and a hydrogen over here. This hydrogen goes, right? This hydrogen goes. So what is left? Only the nitrogen and hydrogen over here, and then we have a bond that goes, that stretches out like this, but it's just stretching out. There is no significance of it. One second. All right, and then we have on this side the carboxylic acid functional group, as we can see, the C, the double bond O. All right, we have to make it small. Then we want to do the on this side. And then the same structure will repeat again over here between these two, right? Just duplicate. I think the distance would be the same. Yeah, the distance is the same. I just not. Okay. And then at the end, we should have one carboxylic acid functional group just attached. Okay. What the heck? So this is how our structure should be. If you want, you can draw brackets. If you don't want, you don't have to draw brackets. Okay. Next, A mixture of three amino acids A, B, and C can be separated, and the amino acids identified using paper chromatography. Complete the equation for RF. What is the equation for RF? So, what is the equation for RF? Distance
Moved by the
traveled by
the
solute,
substance.
yeah,
Yeah, divided by the
substance,
distance traveled by the solvent.
solvent front. Yeah, solvent, yeah, solvent front. Distance. Just copy it. I'm not feeling. Solvent front. That is the formula of RF value. All right. Next question. A sample of the mixture of three amino acids A, B, and C is placed onto the baseline and a chromatogram is allowed to develop as shown in figure 6.5. The finished chromatogram is shown in figure 6.6. Mixture placed here, baseline, solvent, dot, dot, spot, yevo. The amino acids A, B, and C are colorless. Water is used as the solvent. Explain why the baseline is drawn in pencil. Why is the baseline drawn in pencil?
It's insoluble.
Very good.
Pencil
Pencil
is
contains graphite, which is insoluble, right? Pencil does not dissolve. State the type of substance used to make colorless amino acids visible on the chromatogram in figure 6.6. If we do not have the amino acids colored, if we can't visualize them because they're transparent, we use what we call locating agents. We use who? We use locating agents. Why do we not call them chemical indicators or colored droplets या कुछ ऐसी चीज? Because it's not necessary that locating agents are actual physical things. Locating agents could be some radiations, some lights. जैसे कि, for example, when you go further in your studies and you actually perform chromatography, sometimes a lot of the organic compounds are transparent. We have them, we make them undergo chromatography, and then we observe them under UV light. So under UV light, they shine a different color, like the way the cheating pens work, right? Cheating pens basically have a UV light and an ink that can't be seen when normal light is shown on them. Shown meaning shine ka past, I think. And when we shine UV light on those cheating pens, we can see them because those organic liquids can't be observed in normal light. They can only be observed when locating agents are there. So similarly, locating agents is the and next question, explain why in figure 6.6 only two spots are seen from the mixture of three amino acids. So why do we only see two spots from the mixture of amino acid? Where is the third spot? Where is the third spot? So if we
that
want
means
to,
one of them have the same RF value.
oh yeah, very good. So one of them should have the same RF value. Basically, what this means is
Or
two
should be
of
the
the three
same
amino acids
substance.
are traveling at the same pace or they are the same substance. All right, two of the three amino acids should SHO should have the same RF value. Full stop. ठीक है? Because it's one mark, we don't have to elaborate, or they should be, hence they should be the same substance or whatnot. Suggest how the experiment can be changed to separate all three amino acids. How could we separate the three amino acids? Beta, the separation depends solely on the solvent used. In some solvents, they travel different at different pace. In some solvents, they will travel at different pace. So we should always, if we don't get good RF values, we should try a different solvent. Try a different solvent. All right. So whenever you want to get a better result, how the chromatography could be improved. If someone asks you how the chromatography could be improved, use a different solvent. All right. That is how we do it. And with that, this paper is completed. And do you guys have any questions?
No.
No, sir.